Okay, now in the assess, the standard form questions and the indices questions are very repetitive, so what I'm going to do is ignore all of that, just do a couple of ones involving storyline. So question 11, I really fancy doing question 11. This is the assess on page 24/25, but question 11 is on 25. It's rated at grade B. It says the mass of a hydrogen molecule is this, so I've got 3.3 times 10 to the power of minus 24 grams. Now that's the mass of a hydrogen molecule. So there you go. If you're into science, hydrogen gas molecule floating around as a discrete molecule, weighing very little indeed. Now I think you can see that if I was to write that in real numbers, that'll be 0.0000000. I've lost count already. So as you can see, we need a new way of writing very small numbers. That's why we've agreed standard form sort of globally, and the notation for doing that, and avoiding all confusion. So that is a great way of writing a small number, so writing 0.23 zeros and then 33 at the end of it. So I'm sure you can see the picture there. So that is a single hydrogen molecule, and 1 litre of hydrogen contains, this is a litre of the stuff, contains 2.5 times 10 to the power of 22 molecules. Alright, so 1 litre of gas, of this particular gas, contains this many hydrogen molecules. As you can see, it's better than writing 25 followed by another 21 noughts. It makes it very cumbersome, plus you lose track of how many noughts you've written down on the paper anyway. Alright, so standard form is brilliant. Question says, what is the mass of 1 litre of hydrogen? Well, I've got this many molecules in the litre, and each one weighs this much. Essentially, this question is about multiplying, so off I go. I've got 3.3 times 10 to the power of minus 24 multiplied by this many of them, which is 2.5 times 10 to the power of 22. What is the mass of 1 litre of hydrogen? Doesn't say put it in standard form. Just pick up my calculator. I think I'm going to go for 3.3 multiplied by 2.5. That's going to give me 8.25 times 10 to the power of minus 24 plus 22 gives me -2 grams. So a litre of hydrogen gas weighs 8.25 times 10 to the power of -2 grams. Put it in real money, go back twice, doing 0.0825 grams. So here we go, real figures now, real masses in bits of a gram. So a whole litre of hydrogen gas will weigh 0.0825 grams. Not very heavy, is it? You wouldn't even know you're carrying anything. So that's that question. I think it's a real beaut. Now question 12 deserves its own page. It's rated at grade A, and let's just jump straight in and make this last question. And we've got the Earth is approximately a sphere of radius 6,400 kilometers. So let me draw a sphere type thing. So that's meant to be in 3D. I've got radius there, and I'm going to say radius equals 6,400 kilometers. So that's the Earth. So let's just call that Earth. Alright, it looks all nice. And it then says use the formula, and they give us the formula again, 4 divided by 3 times pi times radius cubed, to work out the approximate volume of the Earth, and then give your answer into standard form in cubic meters. Well, if I have to put it into cubic meters, why don't I change this into meters now? So that's going to be 6,400 multiplied by 1,000 meters in a kilometer, 000 meters. Let's just check. Multiply by 1,000, doing. Yeah, that's correct. So I've now got to work out the volume of the Earth in cubic meters, in other words meters cubed. So here I go. So the volume of the Earth is going to be 4 divided by 3 multiplied by 3.14. It's traditional to take it that far and no further, multiplied by 6.4 times 10 to the power of 1, 2, 3, 4, 5, 6. 10 to the power of 6 meters. Now that has all got to be cubed. Now again, my calculator can handle it handsomely. What I'm going to do is multiply this little bit first, just to get that out of the way, to make things less complicated. So 4 divided by 3 multiplied by 3.14 gives me, I've got 4.18666. Say that'll be enough. Multiplied by, now look, I've got to cube the 6.4, so 6.4 cubed, got a cube button here, and that comes to 262.144, multiplied by 10 to the power of 6 raised to the power of 3. Remember, we multiply the 6 and the 3, that's times 10 to the power of 18. So let's tidy this up with a calculator, multiply those two bits, see what we get. So we've got 4.18666, lots of sixes, times 262.14, another 4, equals, that gives me 1097.509. I'm going to stop there because it's getting very cumbersome. So essentially 1097.509 times 10 to the power of 18. Well, I want to write this in standard form. So if I'm going to go back 1, 2, 3 places, I will get 1.097 times 10 to the power of, if I go back 1, 2, 3, I've got to pay it back 3 places, so that's going to be 21. Alright, if I really want to round it off a little bit more, I want to call that 1.1, again the 9 push the 0 up to a 1, times 10 to the power of 21. I've not changed the power, I've not changed the order of it in any way, so that's fine. Just recheck the question, write it in standard form in cubic meters. So that's as far as I want to go. I don't want to round it off to 1 and ignore it. That'll be fine. Part B says the mass of the Earth is, let's take a look. The mass of the Earth is this. So this is part B of the question, requires its own page I think. 5.97 times 10 to the power of 24 kilograms. There you go, it's quite heavy, isn't it? As you can see, it's better than writing 597 followed by another 22 zeros. Much better to have the shorthand there, the standard form way of doing things. And that's my mass, and we're told that density of the planet, or density of anything, is going to be the mass, in this case the mass of the Earth, divided by the volume of the Earth. Alright? And we've got to work out the density, get an approximate answer, and give me answer in standard form as well. Well, the mass is there. I've got 5.97 times 10 to the power of 24. I've now got to divide by the volume. Let's just go back and see if I can find it. Yeah, 1.1 times 10 to the 21. Go forward. So 1.1 times 10 to the power of 21. It looks like a very, very unfrightening sum, doesn't it? That's going to be in kilograms, and that's going to be in meter cubed, I believe, from before. Let me just check that. Yes, I've converted it all into meters. I better put down meter cubed here, just for completeness. Alright, so now I'm going to happily divide 5.97, divide that by 1.1. That gives me 5.43, rounding to 2 significant figures. So he says 5.4272727, so I'm happy just to round it a little bit, times 10 to the power of, well, 24 take away 21, 3. They want me to leave it into standard form to an appropriate degree of accuracy. Approximate accuracy, that's okay, 2 decimal places there. I'm happy to go 2dp there. And what's it measured in? Well, I'm dividing kilograms by meters cubed, therefore the density of the Earth, according to the figures they've given us, is 5.43 times 10 to the power of 3 kilograms for every meter cube worth of Earth. And that is it. Now, I think I want to do the exam question also. I've got that in my notes that I plan to do that, so I better just do that and just have it done with. I've got here 1A, that's page 25. It's the AQA exam style question. It says, explain why 36 times 10 to the power of 18 is not standard form. Answer, it should be 3.6. Now look, I've made it go back one place, therefore pay back the power, times 10 to the power of 19. Alright, again, it's this thing about not doing it your own way. The agreed notation is a single integer, then the decimal place, then decimal point, then as many decimal places that follow. So that is the correct way of doing it, and I've explained it by demonstrating the correct answer. B says, the mass of Saturn, we're going planets again, the mass of Saturn is 5.7 times 10 to the power of 26 kilograms. I seem to recall that being heavier than Earth. And the mass of Uranus is 8.7 times 10 to the power of 25, still heavier than Earth. And the question says, Saturn is heavier than Uranus, obviously, power of 26 beats a power of 25 any day. How many times heavier is Saturn than Uranus? Give your answer to an appropriate degree of accuracy. Well, basically, how many times does that number fit into that number? Essentially, we have a division sum. So here we go. Again, this is all about decoding what the question is about and deciding, am I adding, am I dividing, am I taking away? I hope I don't make a mistake, I'm talking a lot here. Times 10 to the power of 25. 25. Spoke too soon. Pick up my calculator. I'll do the numerical part first. 5.7 divided by 8.7 gives us 0.66. I'm going to call that because it's 665. I want to go to two decimal places maximum. Times 10 to the power of 26 take away 25 is going to be 1. It wants it in standard form, I believe, therefore I've got to go 6.6 times 10 to the power of. If I go forward one place, I've actually used up that power, so 10 to the power of 0. Now you may recall that 10 to the power of 0 is actually 1. Any number to the power of 0 is actually 1. So essentially Saturn is 6.6 times heavier than Uranus. Alright, that's essentially what it is. And that's the answer done, and that's brilliant.